Hi guys, welcome to lesson 1-4, properties of real numbers. Our objective for today is that I can identify and use the properties of real numbers.
Essential understanding. Relationships that are always true for real numbers are called properties, which are rules used to rewrite and compare expressions.
All right, so vocabulary for today, we have equivalent expressions. These are algebraic expressions that have the same value for all variables. Simplify with variables means we are going to find the equivalent expression with no like terms and no parentheses remaining. So we are going to combine like terms and that'll be it. Deductive reasoning is logical reasoning from given facts to a conclusion. So you are using the information you have to draw a conclusion. And a counterexample is an example showing that a statement is false. So it's evidence that something is false. All right. So we've got our first property here. It is the commutative properties of addition and multiplication. And what this basically says is that when you change the order of the terms, it does not change the sum. If you change the order of the factors, it does not change the product. So a plus b is the same as b plus a. 18 plus 54 is the same as 54 plus 18. A times b is equal to b times a. Order doesn't affect it. 12 times 1/2 and 1/2 times 12, exact same answers. The associative properties of addition and multiplication changes the grouping, but not the sum. So if we've got a bunch of terms that are being added together, the sum will remain the same even if you group them differently. So one thing I like to reference in associative is you associate with a group of people. That's how you can think of grouping symbols.
I think of it as at lunch, A and B sat together the other day, and then B and C sat together. It's who you associate with. Think of the lunch tables.
Yeah. Multiplication is the same rule. When you've got a bunch of terms that are being multiplied together, you could group them in any way you would like. So you could have A times A, the quantity A times B times C, or A times the quantity B times C. And again, it's going to come out to the same exact answers as Ms. Zirzo demonstrated. All right, a couple more properties of real numbers. We've got the identity properties of addition and multiplication. So the identity property of addition is when we just add 0 to anything, it remains the same. So 5 3/4 plus 0 is still 5 3/4. The identity property of multiplication is when we multiply by 1. This will come up when we start dealing with fractions. Let's see, the zero property of multiplication, zero product property. Anything times 0 is 0. Doesn't matter what it is, anything times 0 is 0.
This is my favorite property.
And the multiplication property of -1. It's Ms. Zirzo's favorite. The product of -1 and a is -a. All right, so let's simplify each expression and identify what property is being shown here. So 42 times 0 is equal to 0. All right, multiplying by 0, so that's going to be that 0 property of multiplication. Pretty obvious one. We've got y plus 2.3, the quantity, plus 10, and y plus the quantity, 2.3 plus 10. Associative property of addition.
Don't abbreviate associative too much.
Yeah.
8th graders.
Yeah. All right, 12x plus 0 is equal to 12x. Hey, that looks like an identity property of addition. Adding 0 to it doesn't change the sum. And 4 times x and x times 4, that appears to me to be the commutative property of multiplication. So why don't you give the next 6 down below a shot, and we will run through the answers after the break.
Go back and check your notes.
All right, so letter A is going to be commutative, associative property. We got the groupings. We've got the zero property of multiplication. Letter C is going to be the commutative property. Letter D is going to be multiplication property of -1. Letter E, that looks like associative. We've got grouping symbols. And letter F is a tricky one. That is the identity property. 4 over 4 is 1. Try to trick them. I don't think I got them. All right. Problem number 2, writing equivalent expressions. We're actually combining problems 2 and 3 into the same step here. So, simplify the expression and justify your work. What we are going to do, you need to first do the distributive property. 4 times 8 is 32x. And that's our only term. That's all we can do. We're good with that. All right, letter B. So we've got the associative property involved here. So we can do 4x plus 9 because we are just going to add each of the terms together that are like terms. So the way the associative property would apply there is we would rearrange it and say 4x plus the quantity 6 plus 3, and 6 plus 3 is 9. All right. All right, 8m over 12mn. The m would cancel out in the top. So we'd be left with 1 on top. And 4n in the bottom. Our 8 over 12 reduces to 1/4. 8 over 12 reduces to 1/4?
I knew what I meant.
2/3.
That's what I meant.
All right.
What property did I use? I just reduced.
Yeah, just reduction. So no property on that one. 8xy over 2x. So again, we can just reduce. The 2x's are going to cancel. 8 divided by 2 is 4, and we are left with a y. All right, letter E, we've got a word problem. A can holds 3 tennis balls. A box holds 4 cans. A case holds 6 boxes. How many tennis balls are there in 10 cases?
I hate these problems.
For the record, guys, these are the kind of problems you're going to get in science and chemistry. Maybe not with tennis balls, but they will be using units, and you will have to cancel them out and all kinds of good stuff. But let's just start with this. We know we have 10 cases, so we're going to say 10 cases times. Well, there are 6 boxes per case, so we're going to multiply by 6. So now we've got boxes. There are 4 cans per box. We're going to multiply by 4. And then there are 3 tennis balls per can, so we're going to multiply by 3. 10 times 6 times 4 times 3. $720. Very good. Mrs. Zirzo remembered that there were units in our question, so we needed to have units in our answer, and there are 720 tennis balls in 10 cases. All right. Why don't you guys give letters B, C, and D, or A, B, and C a try, and we will go from there. All All right, so letter A, we use associative property to mix and match there. We got 7x plus 5. Letter B, we're just going to be canceling a bunch of stuff out. So we're left with 2y. And letter C, we're going to start with the, well, I would have gone step by step and said we start with the inside. 5 times 2x would be 10x, and then 3 times 10x is 30x. We should show all of our steps, Mrs. Urzo.
I'm trying.
All right. Problem 4, using deductive reasoning and counterexamples. And we want to know, is this statement true or false? And if it is false, give a counterexample. So for all real numbers, j and k, j times k is equal to k plus 0 times j. Well, that would seem to be true to me. You are not changing k at all. That's the identity property of addition, so k remains the same. jk and kj are the commutative property. So we got two different properties in play there, and that one is true. So letter B, for all real numbers m and n, where the m times the quantity n plus 1 is equal to mn plus 1. And Ms. Zirzo did the distributive property and demonstrated to us that if we actually did distribute this, you would be missing an m term on the right-hand side of the equation. So it would be false. So you could plug in any two numbers you wanted for m and n, and they will be false. So why don't you guys give it a shot? We've got an example here in the bottom. For all real numbers, x and y, x times y times 0 is equal to x times y. Give it a shot and see what you think. It is false because anything times 0 is going to be
0.
0. Thank you.
My hero, 0.
All right, guys, here we are, end of the lesson. Once again, rate your level of understanding on this lesson. I know this is kind of a topic that may be new to some of you guys. You will possibly have lots of questions, so make sure you write those down if you have them. We will address them in class. You need to memorize these properties because they will come in handy as we start to solve equations. You will hear us referring to properties, and if you don't know what we're talking about, you're going to be lost later on. So make sure you guys are keeping up here. And remember, the more you write, the more you remember.
Some of my kiddos think they can sum up a whole entire lesson in 2 sentences.
That's not the case?
That's not the case.
All right. Well, you know who you are. You know who she's talking to. All right, see you all tomorrow.